Yo, what is up, everyone? How are we doing? How are you doing? How are you doing? Hold on, let me just answer this question inside the Discord. Cobalt. Which model? With different chats, templates. So you would need to account for that, I would think. Alright, yeah, okay. We are, again, doing a little bit of a shorter stream today. We are just going to be reacting to some of the stuff that you guys have submitted through the forum. If you haven't done so already, you guys can submit more, I guess, articles, papers, even videos if you want me to react to those through the forum. And we're just going to keep using that forum moving forward for these kinds of streams. 1 minute late. I am technically okay. Haku, you gotta realize that when I say 15 minutes or whatever times or like whatever amount of time from when I give you guys the heads up, I'm always rounding to the hour. I mean, like I assume you know that. 1 minute early? Yeah, that's right. I'm always early, always punctual. When have I ever been late? Every freaking time. Yeah. I only see one article currently accepted, reviewed and accepted. There were some other articles from the previous streams that I never got around to reading. I don't actually have the link for those anymore. So if you could submit it there again, then I can probably take a look at that. You submitted one? Yeah, it looks like we have a couple inside of the spreadsheet already, but nothing really has been reviewed yet. Oh, the chess and the LLM stuff? Yeah, that one got approved. So I'll be taking a look at that one right now. Let me just finish reading what's in the Discord. But yeah, if you didn't see the ping like 15 minutes ago, we just finished releasing version 2.2.0, which contains all the MCP and MelloTTS stuff, as well as some of the fixes to the dependencies that I was talking about, like Wave and MySQL just being broken. Even though we don't even use those, they're built into Conda, so we kind of do have to provide a fix for those dependencies. Or at least just pin them to the correct version. Isn't there a story about a guy that was too early to his job and died in a gas leak? Seems oddly specific. But I don't doubt it. Probably happened. Alright, let's pull up one of the articles. Oh, we actually got some more accepted now. I'm not reading through the... Okay, you don't need to read through the article, Haku, or any of the other mods here as well, Noel. You guys don't need to actually read the article. You guys just gotta give it a first glance and be like, yeah, this is not gonna get me banned or whatever. Or this is actually something I can properly react to. Let's get started with the first article here. I believe this is yours, S16. Let me transition scenes. This is can an LLM play chess? Oh my god. You know what this reminds me of? I was actually thinking about this. I was actually, one of the first games that I wanted J.A. Eisen to be able to play was going to be chess. Because it's like pretty simple, I would feel like, to implement, right? But the only thing is just like, is there even an API for something like chess.com, or is there a site where I can easily make a bot to play the moves, or am I gonna have to use something like Playwright or mediate it myself, right? I was thinking like, if I couldn't like make some sort of, I guess, bot that automatically takes Jay Eison's moves and plays them out on the board, there's something really scuffed that we could do is just like take a screenshot of the board, send it to Jay Eisen, ask her for a move, and then I just manually do the moves for her. You're rewriting or hooking into someone else's CLI chess game? I feel like there should be a way for us to make chess spots on something like chess.com. Or maybe not chess.com, but on some sort of other chess site, right? Maybe. Alright, but this article, can an LLM play chess? What I was originally going to say was that this reminds me of, have you seen that one Gotham chess video when ChatGPT was like first popping off and he was like, you know what, we're gonna have ChatGPT play chess by giving it the board exactly how I like described it to you, and then he did the moves for it, and how it would just completely hallucinate every single time.
I am fighting with Windows to start seeing Wi-Fi options and not turn off randomly on my laptop. I am considering adding Duo Boot to Linux. Windows hates me for some reason. For sure is not that I use cracked version, not like this lol.
Okay. I think that's a skill issue. I've never had that problem with Windows before. Yeah, the videos of freaking of him trying to get ChatGPT to play chess without completely hallucinating and completely breaking down is just like peak. Actually peak. But I don't remember. Was he using the context window of ChatGPT to store the moves and then have ChatGPT try and infer the board off of the list of moves? Or was he taking screenshots? Because I don't remember if computer vision or just image submission in general was in ChatGPT at that moment. I don't know. Maybe we can try something like that. The Gotham method. It's super simple. We could do that with current Jay Eisen, right? It's just text. If he didn't submit any images, but it would be nice if we have the ability to like send images to Jay Eisen. That can be something that I can work on next week. Yeah, let's get into this. My experiment with YOLO and Gemini. What's YOLO again? I don't remember what YOLO was in the context of AI, but you know what, that's fine. Imagine giving Jay Eisen access to AlphaGo. Yo, Jay Eisen versus... Wait, is AlphaGo is that the AI bot, or was it Deep Blue? I forget. Deep Blue. Deep Blue AI. No, Deep Blue is for chess, no? Yeah, Deep Blue is for chess, and then AlphaGo is for the game Go, right? Yeah. Jay Eisen versus AlphaGo, who would win? YOLO is a zero-shot image segmentation and detection. Okay, that makes sense. So, using YOLO to parse out the image, I would assume, and then feeding that information into Gemini for Gemini to make the moves. Okay, let's see this. Introduction. Chess is one of the most complex games ever created, with a virtually infinite number of possible move variations. Computers have been outperforming humans in chess for decades, with engines like Stockfish, gotta love Stockfish, and AlphaZero, okay, AlphaGo, but for chess, demonstrating near perfect play. But what about large language models? Can an AI trained on human language develop an intuition for chess? I mean, it can definitely develop the intuition for chess, but I don't think there's how much of chess theory is actually written out in text? Or would they have data sets of like chess guides or like move scenarios or whatever, and then have it actually be described? Because I feel like learning chess at a high level is more about running scenarios than it is about like actual textbook strategies, right? I don't know. Because I don't really think there's like a lot of data sets out there outside of like actually analyzing game histories, but I don't think that can easily be converted into text to train these sorts of large language models like Gemini or ChatGPT. I decided to put this idea to the test by integrating two powerful AI tools. YOLO V8N for real-time chess piece detection. Okay, so this is analyzing the board. And then Gemini 1.5 Flash fine-tuned on a chess tactics dataset. Okay. It's only chess tactics, so this is more like textbook moves, I would say, to suggest moves based on board positions. Okay, so here's how it went. Building the chess AI system, live chess detection with YOLO V8. To make this system interactive, I needed a way to visually recognize chess pieces from a 2D digital chessboard. I trained YOLO V8N model on a dataset of 2D chess positions, teaching it to detect pieces and their placements in real time. Teaching it to detect the pieces and their placements in real time. I assume by real time, they probably just mean once every single move. I don't think they would necessarily need anything more than that, because it's not like board state changes in between moves or anything. The goal was to extract the FEN, whatever this is, string representing the current board state. This is probably just some chess terminology for like representing. Oh, okay. So the YOLO V8N, this actually looks at the image, but it outputs text. And the text that it is going to output is going to be stating where each chess piece is. So it'll be like knight b8 or something like that, right? But it would do that for every single piece inside of a string, and so that would represent the board. And so you can insert this into a text-to-text LLM, so it doesn't necessarily have to be multimodal. Using OpenCV and MSS. What is MSS? Not sure. My program captured the screen, passed the image through YOLO, and generated a FEN string. This FEN was then used as input for the next stage. Thank you, RDG, for gifting a tier 1 sub. Wait, who got the tier 1 sub? It doesn't say. Oh, what happened to the bitrate? Does the stream look scuffed for you guys as well? It looks really blurry for me. A vacuous. Okay. Congrats to a vacuous. Step 2. Using a fine-tuned Gemini model for move prediction. The second part involving leveraging Google's Gemini 1.5 Flash model. Since general-purpose LLMs are not trained to play chess, I fine-tuned Gemini with a dataset of chess tactics. This dataset contained FEN positions, okay, and the best move in UCI format. Again, more chess jargon that I do not understand. The idea was to train the model to suggest an optimal move given in FEN string, right? So they probably aren't giving it like the entire history of all the moves made in the game. I think they're just passing it like, okay, here's a chess state. Predict the next move in the future that you should do, right? It's going to be a singular input instead of a history of inputs. And I feel like it would be interesting to see how it would perform if it was given a series of states, right? A bunch of like previous states leading up to that moment, so the LLM can kind of understand how the opponent is playing because it's not like humans are. It seems inefficient because history teaches you the other player's strategy. Yes, that's what I was thinking, right? The history would kind of encode or kind of suggest how the opponent, the human opponent, is trying to play, because like it's not like they're always making the most optimal moves, right? Otherwise, every single player would be like Stockfish or something. But it would be interesting for the LLM to have that kind of context and then kind of decipher, okay, is this guy playing more defensively? What is this guy prioritizing and stuff like that? And then they would be able to make more contextualized actions as opposed to just looking at a single state as though it's a chess puzzle or something like that. So challenges and discoveries. LLMs are not great at chess. I think Gotham's right on this one. Unlike chess engines like Stockfish, LLMs don't calculate millions of positions per second. I was talking about this before, right? LLMs can't really think ahead in the future. They can only think in the moment, which is why we have this concept of thinking models, right? Because they can only think in the present, they think in the present, or because they can only generate stuff in the present, they basically think in the present, and then when it comes to actually responding, they will have already done the future thinking, and so they have the entire concept or idea inside of their thinking block to which they can use to guide their response, right? LLMs don't really have this concept of thinking in the future. Once they output something, they use that output to then influence what they're going to generate next, but it's not like they can generate what comes next to influence what they're going to say now. So yeah, it's not like LLMs are going to be able to perform like Stockfish, where they can branch out and explore different scenarios. They're just going to do what's statistically the most predictable in that situation. But I guess like, if it's a textbook move, it would be kind of hard to say. But in most situations, it wouldn't really come down to a textbook move. Yeah, it wouldn't really come down to a textbook move, so it wouldn't really be in its training data set how it should perform in a more ambiguous situation, right? And so, yeah, it would fail really hard when it comes to future planning. And so I guess that would be, I would like to see how it would perform if the model was a thinking model. Is Gemini a thinking model? Is Gemini a thinking model? Like, when was this published? Back 2025, March. Thinking model should be out by then. It seems like it was introduced in 2.5. Yeah, it was introduced in 2.5, and they said here that they were using the Gemini 1.5 Flash model. So this is not a thinking model, but I feel like if it were a thinking model, then maybe it could be better at chess, if that's the case. I really do think it could be good at chess if it is a thinking model, because then it can actually think into the future and at least explore a couple scenarios, correct its own thinking, and then make the best move off of that. Technically, all models are thinking if you fine-tune them, though. Yes, but the thing is, they didn't fine-tune it to behave like a thinking model. They simply just fine-tuned it to only output a UCI best move, right? And nothing else, really. So there is no thinking going on, really. There's no pre-thought. There's no, like, explanation of why it thinks it's the best move. It's simply just outputting a UCI move. Then they're taking that to play the move. I think OpenAI's models were a little better at chess. I'm not sure. Because The only time I've ever seen OpenAI's model play chess is just through that Gotham video, which answers the reasoning equals better at chess question. Which models from ChatGPT use thinking? O models, all O models, right? Okay. Well, I haven't seen any O models play chess yet, so I don't really know how they perform. This is a surprising discovery. I mean, I don't think it is that surprising of a discovery, given what we just explained. Even though Gemini was fine-tuned on thousands of correct chess moves, again, these are textbook chess moves, not actually like regular gameplay scenarios, which are like 99% of the time, it failed to grasp the logic behind move selection. I suppose. I suppose that given some sort of FEN string, it should be able to at least infer out what would be a good move in what situation, but yeah, still it is lacking that ability to explore different branches, which is kind of a big part in the reasoning for certain moves, right? It's not like textbook single instance moves will get you through and give you the best decisions 99% of the time, I feel like. There needs to be some sort of future thinking, and so, yeah, it would... Maybe we should do it. Maybe we should be the ones to try out the thinking model and see how it performs with, I don't know, Gemini or whatever, 2.5 Pro. If we record and convert thousands of human versus human games from chess.com into a format and teach the LLM, with like 3 to 4 move history, we might get somewhere. Yeah, we might get somewhere. And I think it would have to be longer than 3 to 4 move histories. We can definitely encode a lot more. We can definitely have a much larger history because, again, these API models have huge context windows, right? And these FEN string formats, I don't think they'll be too big, right? Because what? There are... how many pieces on a chessboard? Like 3, 4, 8, 16. There are like 32 chess pieces on a board at any given time. So the strings really shouldn't be that big. But yeah, it often suggested illegal, random, or suboptimal moves, proving that simply training an LLM on FEN best move pairs is not enough. I also wonder how they set up the parameters for generation, right? How much temperature there was, what kind of sampling they were using. Because I feel like the randomization from the samplers alone would make it a really crappy decision maker. Because you're not selecting the best, most probable move every single time. If you're using a stochastic sampler, right? You might end up with a suboptimal move simply because it is randomly selecting. But yeah, the complexity of chess is a bottleneck? I don't think so. I think their setup is just not adequate enough to set up the LLM for success. But let's just see what they say. Chess engines work by evaluating positions deeply and efficiently, but LLMs are not built for structured reasoning. Well, maybe try a thinking model. With billions of possible board positions, predicting the next best move is far beyond their typical use case. The more complex the position, the more the LLM struggled. Yeah, because again, it's not textbook scenarios, right? And without the ability to think inside of non-textbook scenarios, it's just not going to work. This showed that fine-tuning an LLM on chess does not grant it true understanding of the game. Instead, it learned how to answer based on patterns of the dataset, but failed to reason about the position itself. I'm not really satisfied with this article, I'm not gonna lie. Noel says, I worry about light M. What is LITM? Even a local model with 32k context can store way more moves than that, but attention isn't a magic fix for everything. Yeah, attention isn't a magic fix for everything, but at the end of the day, an LLM is still a neural network, right? And I feel like no matter the architecture, it should still have the capability to learn the relationship between moves, a like FEN string towards the most optimal move, right? It just depends really on the setup of everything. In part, the point of using a transformer is that you want some randomness. If you set things to greedy sampling, why not just use stockfish? Well, the point that I'm getting at here is like, yeah, LLMs, when you're trying to talk to it for the sake of talking, then you would want some sort of variation to speech. Otherwise, it's always going to output the same string, the same response for, if you were to say hello, then it would always say hello back, right? You're never going to get some sort of different response like, hey, how are you, whatever. But in this case, I feel like what we want to see is whether the architecture of a transformer itself is capable of coming up with winning solutions, or at least the LLM is capable of reasoning about a board to come to a optimal solution, right? But I feel like in this experiment, they aren't giving it the opportunity to do either. They aren't giving it the opportunity to reason with some sort of pre-thinking, and they aren't giving it the opportunity to use its most likely, I guess, response, right, in that situation. LITM is lost in the middle. Okay, what is LITM though? LITM. Is not it. AI. I have no idea what LITM is. It's when information in super long context gets lost. Is that what LITM is? Let me just get this prediction for you guys. Damn gamblers, Hezwan. This paper. Oh, okay. Lost in the middle. That's what you mean. It's when information in super long context. Yeah, okay. So lost in the middle, right? This concept that that information at the beginning and end of the block of text is what's given the most attention, but then whatever is in the middle is kind of like forgotten. I guess that's mainly because of like, well, it might be a emergent like behavior that we see in a lot of LLMs, but I feel like a part of it is also kind of influenced in how people pay attention and how these data sets are created, like how people pay attention. There is also this principle. I forget the rules and I forget the what are they called in psychology, but humans as well, they also tend to only remember things from the beginning and the end, more so than they do the contents from the middle, right? And so I feel like that also translates and has been ingrained into the data sets and has been what it appears inside of the AIs that we train as well, right? Okay, that was an interesting read. I feel like it's like pretty good for seeing a basic setup for how to get an LLM to try and interact with a chessboard and play with chess, like YOLO, using YOLO V8 to parse out a chessboard and actually getting out a FEN string, to which we can probably give to something like JAISIN to figure out a move. But yeah, overall, in terms of the actual findings of this paper, it's not great. Also, wait, we're nowhere near. I just realized we're nowhere near the bottom. Hold on. Because this is just the mailing list thing. We were here, right? Okay. 3. Free access is limited. I wanted to test reasoning focused models like Gemini. Reasoning focused. This isn't thinking models. This is what he means by, or who's this author? I don't know. What they mean by reasoning focused isn't really thinking models, but it's more like models that have generally better logical reasoning ability in terms of their responses. So stuff like Gemini 1.5 Pro, Claude Sonnet, things that aren't ChatGPT, really. But most require a paid API. Google's Gemini's limited free access allowed me to experiment, but without a premium model, I couldn't push the limits further. Well, you're writing an article for the Medium. I would expect maybe $5 of your time. Yeah, it's not thinking models. When they say reasoning focused, they simply mean models that are better at logical benchmarks. That's it. Testing reasoning-based LLMs. Since Gemini 1.5 Flash struggled, I plan to test more advanced models that prioritize reasoning over pattern recognition. GPT-4 Turbo. This is still not a thinking model, right? This is still just a normal model. Gemini 1.5 Pro and Claude Sonnet might perform better if they have deeper logical reasoning capabilities. Again, still not thinking, just better performing on these benchmarks. $5 is $5 too much? Okay, guys. Like, once you, I don't know how old most of you are, but like, you go to a vending machine on campus in university, you buy one monster, boom, that's $5 right there. So it's either you do this experiment for the Medium, do it well, or you buy a monster on campus. Which one sounds better to you? The monster? Oh my god. It's fine, I got access to the fine-tuning resources to glob together 70 billion models. $5 for monster? Yes, it is highway robbery inside of the university. Everything's just so much more expensive. Beer is cheaper. Beer is cheaper. It's just anything on campus, really. Anything on campus is like marked up 200% or something. Sodas are $25. Nah. Not in this country, what? Oh, 25 cents. 25 cents, bro. 25 cents? What are you, living in the 1900s or something when they first released soda? Not even in the cans, just straight up in the bottles when Coke still had Coke inside of it? I keep track of the price of Pepsi and Coke per liter. 25 cents is egregiously low. Yeah, this is, again, not good. Using RAG with a Bro, this is overkill. What the fuck? What are you even gonna RAG? Yeah, let me just Google this position really quick. What is the most optimal position for when knight is in B8? Yes. Like, what is this? And with a vector database, what are you encoding in here? Are you gonna take like the entire handbook for optimal moves and turn that into embeddings, store that into a database? Like, what's the purpose of this? You're still not getting textbook moves. A major limitation of fine-tuning was that Gemini often hallucinates moves. And what is a vector database gonna do here? What is a vector database gonna do here if you're already giving it the entire board state and it's still hallucinating? Like, what? Okay, I get it. It's a shit dog. Not gonna lie, I had high hopes for this. Yeah, I had high hopes for this one as well. But didn't you submit another one with about chess? Oh no, that's ChatGPT playing Tetris. Let's just keep seeing what this guy's cooking. A possible fix could be using a RAG. This guy probably heard RAG once and heard how it fixes hallucinations, and then this guy was like, yes, hallucinations in my chessboard? RAG, that's the solution right there. RAG system, where the model does not generate moves blindly, but retrieves relevant tactics from the vector database containing chess positions and their best moves. Oh, I mean, this is not gonna solve hallucinated moves, but I kind of see what they're meaning, right? Maybe to concretely provide the manual saying, okay, in this position, this is, or this similar position, this is what the best move was played. I guess they can do something like that. But it's not going to solve your problem with hallucinated moves. Instead of relying solely on the LLM's memory, a RAG system could search for similar chess positions and fetch pre-computed best moves. Pre-computed as in the textbook moves, or are you asking Stockfish what's the best move? This could significantly reduce hallucinations and improve accuracy. I mean, sure, they can search up similar chess positions like I said, and then show what would be the best move in similar positions. But again, it is not going to solve hallucinations. It's not going to reduce hallucinations. And improving accuracy, again, unless if it's the board state is a one-to-one match, improving the accuracy wouldn't be the case if it has to infer. And then it just, like, if its inference ability is already shit, I don't think it'll infer any better if it's given similar positions, right? Because the best move, even in like slightly different board positions, would be completely different. Exactly. RAG? Why not just give it MCP? Boom, solved. MCP to Stockfish. Oh my god, our LLM is suddenly a genius. I wonder what happened. No way. MCP's the future, guys. MCP to 10x your LLM performance. Fine-tuning. This is just ridiculous, this RAG section. Fine-tuning with chess logic instead of just moves. The biggest flaw in my fine-tuning approach was that I only trained the model on FEN positions and best moves, but not why those moves were correct. Okay, we're getting into a little bit more of thinking. We're finally using our brains a little bit. Use plugins? Nah, shut the fuck up. Yes, Stockfish plugin. Stockfish MCP. I'll have a dedicated operation type built into JEISN specifically for chess and specifically for Stockfish, okay? Who needs text filters? You know what? We're going to make a new text filter. We're going to make a new text filter, but it's going to be specifically for Stockfish. So instead of filtering out the response with like a moderation, instead of like chat moderation to filter out a response, instead of filtering it out and
use
giving back,
plugins.
nah. Instead of filtering it out and sending back filtered, we can just send back chess moves. It's so fucking cursed. What is this? I can't believe that message got held back for racism. Use plugins got held back for racism. You know what? Plugins are racist. I can concur. Yeah, for my next experiment, I will try fine-tuning with move explanations. Instead of just learning this move, this position equals this move, the model will also learn the reasoning behind each move, such as this avoids a fork, okay. This capturing here wins a piece, okay. This move sets up checkmate in 2. I mean, sure, it's better, but again, you would need much more deeper reasoning. Like reasoning beyond, okay, this immediate move avoids a fork, right? What about 10 moves in the future? Something like that. We want to think about 10 moves in the future. What would the board kind of look like then? That would be a much better reasoning approach as opposed to, okay, this very next move, this avoids a fork, right? Sure, it might be good if it's a very obvious and a very game-changing kind of fork, which I guess most folks are. But at the same time, it's like capturing here wins a piece. Yeah, no shit, capturing here wins a piece. But like, what does capturing this piece do? Are we trading? Are we gonna win this trade? Like what? Like this guy, the person who wrote this article, it just kind of feels like they don't know much about AI and they don't know much about chess either. And they were just kind of told by their boss, like, hey, you know what would be good for visibility? Writing a blog post on the Medium. That's your job for today. And this guy was like caught playing chess or something, and he was like, "Ah, shit. I guess I'm writing a Medium article about chess and AI now." Yeah, if LLMs can understand the logic behind tactics, they might become better at playing chess rather than just memorizing patterns. Yes, okay, they will become better at playing chess, but like they need more context than this if they want to be better than Stockfish. Conclusion. While LLMs like Gemini can recognize patterns and suggest moves, they are not viable replacements for traditional chess engines, at least not the way this guy made it. However, combining an LLM with YOLO-based real-time detection creates a fun and interactive chess assistant. I will agree with that, and probably I might try this approach as well. This experiment showed that while LLMs have potential in chess learning and explanation, they are far from mastering the game itself. Well, you gimped it that way. You fucking cut off his legs. You took away his reasoning ability and was like, yo, play chess now. Perhaps in the future, with better reasoning models, not better reasoning models, with a thinking model, a simple thinking model which existed at the time of writing, RAG systems, and logic-driven fine-tuning, we might see stronger LLM-driven chess players. Would I trust an LLM to play my next online chess game? Not yet, but it was a fun experiment nonetheless. You know what? I'll give props to this guy for trying. You need to give J.E. Eisen a personality module with a ID, ego, and a super ego in it, shaping how she responds. At this point, we might as well model the entire human like psyche with all of like the different like phonological loops and all of that shit and see where that fucking takes us. Driven by like 20 AIs or something, 20 LLMs, each driving a different part of the human psyche. Oh god. It might be interesting to see, but I don't know. It'd be really hard to model and consolidate everything. One follower. Yeah, he's dumb. Yeah, this is like there are no comments because I'm pretty sure nobody has read this article. How did you even find this article? There has been probably one hit on this article since March. You're just describing Unicara. Is Unicara like Does it have 20 LLMs under the hood? Holy shit. It's like 20 LLMs vying for their personalities to be heard. Someone sent it to me yesterday? Okay, so that makes it 3 hits. 3 people have seen this article. What is this? Is this 6 claps? How many claps does this have? Can I give it a clap? Oh. Do you mind next? We go down the list. We go down the list in which they came in. The next one we have ChatGPT playing Tetris. I don't know who submitted this one. You motherfuckers. I can't believe you. You motherfuckers. Haku! Oh my god, Haku, we're timing out your fucking accepting privileges. What the hell is this? There are 2 so far which define conscious and subconscious. There will be a 3rd for quick decisions. Is it like not brain rot? Is it sloppy to combine the conscious and subconscious into a singular model? Kind of like how, okay, I know you're gonna hate me for this, but like fucking other RP models, how they have stage talk, right? How much does stage talk really hinder, or how much does it really dilute the intended personality? I feel like you could fine-tune a model. It is very sloppy to do that. Because I would assume like it would be alright if you partition out, or if you section out the chat template like properly. If you can specify a section, no, if you can specify a part of the chat template which has like stage talk, right? Stage talk, and then normal user input, and then normal spoken responses. Because I feel like within the different blocks, at least from what I've seen, it does tend to behave differently, but I don't know how much it actually hinders the final results of the fine-tuning when it comes to responding in different blocks of the text, right? I'm not sure. Only whatever short form insight was gained. I never show long thinking context to the conscious model. Only whatever short form insight was gained. I guess that is also better when it comes to reducing the context, the number of tokens you pass as inputs. And so you could probably store more of the relevant conversation history inside of the chat. So I guess, yeah, that is probably a better way to do it, but you just need significantly more VRAM. Or if you're hot swapping, you have to be fine with the extra latency. Limit rickrolls, man. Can't believe I'm getting rickrolled in the big 25. Okay, what about this next one? This is in Arxiv, so there's no way I get rickrolled off this one, right? Wait, what does this say? If this would be a good idea to implement or use within Project JISON, because having a unique way of remembering and processing / reasoning its memory from a few vector database would contribute to its uniqueness. A GitHub with this memory idea exists, but we could modify it for our use. Agentic memory. Okay. So this is an article about agentic memory, or at least some solution for agentic memory. Let's see how this is different from all the other versions we've explored. Cognitive architectures in language agents. How long is this? Holy fuck is the... Right, okay, this is the one that you submitted last week. Oh my god. Limit, all the others were so bad, they put YouTube links. I had to have a custom link. You mean all the other Rickrolls were so obviously Rickrolls? Let's see, let's see. YouTube video to react to? Let's see this. Okay. Oh yes. You know what? Let me quickly show you this form. Yes. 2 of the exact same URLs. What could these be? Oh, Rick Astley never gonna give you up. Rick Astley never gonna give you up. My god. I swear, by a month from now, 50% of these links that are submitted are all gonna be Rickrolls. Yeah, we don't... This is actually the last link, the last submission we have right now. The last actual submission that isn't a Rickroll. I'll filter them, lol. I mean, that's your job as a reviewer, no? Mods gotta have more tasks, you know? Y'all been like too chill lately. This is a long ass article. Okay. This is in reality only 19 pages. We don't get paid, he's scamming us. You guys get paid in exposure, you know? You guys should be grateful that you're my mods. Alright. Let's see if my illiterate ass can get through this. So, cognitive architectures in language agents. Let's see. The abstract recent efforts have augmented large language models with external resources. When was this published? 2024. Okay, this is an old article. Old relative to everything else. With external resources or internal control flows like prompt chaining, or tasks requiring grounding or reasoning. Wait, were thinking models even invented? Or were thinking models even a thing in 2024? No, right? They're like a very 2025, late 2024 idea. Yeah. For tasks requiring grounding and reasoning, leading to a new class of language agents. God. What the fuck does this even mean? You know what? Sure. While these agents have achieved substantial empirical success, we lack a framework to organize existing agents and plan future developments. In this paper, we draw on rich history of cognitive science and symbolic artificial intelligence to propose cognitive architectures for large... I actually cannot read, bro. I cannot read science papers. My brain just like turns off with every single word. To propose cognitive architectures for language agents. Koala. Very nice name. Koala. Isn't this literally pre-Mario, pre-MCP, pre-thinking? Yes, it is pre all of this, although I've never heard of Mario before. What the hell is Mario? Mario AI. I don't know what this is. It's a good read. We'll see. Maybe there's still something that we can learn. Or maybe we can even see like how well these ideas stack up to today. Papers are either good when they're either from last week or over a decade. Exactly. Once they're older than a month, they're like UNC status, you know? We read the ones from like a decade ago because they're like they're like legendary, you know? They're mythical. Mario. Math reasoning with code interpreter outputs. Code interpreter output. A reproducible pipeline. Is this just giving it like a coding environment and letting it try and basically use the environment to produce results, do math, do stuff like that? And no, this was submitted January 2024 and then last revised in February 2024, which is kind of around the same time this article got released. Considerable advancements in... Yes, it's just giving a code environment as a calculator? Okay, yeah. Well, I swear OpenAI was doing this for the longest time as well, right? They were giving like sandboxes or coding environments to the LLM to kind of test its responses or something like that. I'm not sure. I feel like I read that somewhere or heard that somewhere. Yeah, let's continue reading. In this paper, we draw, Koala. Koala describes a language agent with modular memory components, a structured action space to interact with internal memory and external environments, and a generalized decision-making process to choose actions. So it's literally an agent, but it has additional memory modules, which is kind of what I'm more interested in, right? The whole agentic part of it, we have MCP and tools for that already, right? It's just basic function calling. OpenAI code interpreter was really early, yeah. This was specifically using inline to do math in a larger problem like a SAT. Yeah. I mean, I'm still not too sure how this is really different from what OpenAI was doing back in the day. Outside of maybe kind of like their implementation of it, but the concept is still the same. We use Koala to retrospectively survey and organize a large body of recent work and prospectively identify actionable directions towards more capable agents. Which part of this is an agent? This just sounds like a large language model. Prospectively identify actionable directions towards more capable agents. Cognitive architectures for... I don't get it. What is this trying to achieve? What is Koala trying to achieve? What? In this paper, we draw on the rich history of cognitive science and symbolic artificial intelligence to propose Koala, cognitive architectures for language agents. This describes a language agent with modular memory components, a structured action space to interact with internal memory and external environments, and a generalized decision-making process to choose actions. Language agents. Sounds like fancy speak for a chatbot. Well, whenever we say agents, we mean something that can interact with environment, right? So it's not just generating speech, but it's generating tool calls. And then those tool calls, they interact with the environment. Those tool calls return with results. They're feed back into the language agent or the large language model, and the large language model can dispatch the next action. They have a diagram below to show what they mean. Okay, and because it's kind of confusing, because how they describe it here just literally sounds exactly like a large language model without the actual actions taking place or whatever, right? The only action it's giving is, well, an opinion, and that it really isn't much of an action. Taken together, Koala contextualizes today's language agents within the broader history of AI and outlines a path towards language-based general intelligence. Okay, let's see what they say. Language agents are an emerging class of artificial intelligence systems that use large language models. Yep, so it's using a large language model as kind of like the core thinking part, the part that actually decides what actions should be dispatched and whatever. To interact with the world, they apply the latest advances in LLMs to the existing fields of agent design. Intriguingly, this synthesis offers benefits for both fields. On one hand, LLMs possess limited knowledge and reasoning capabilities. Okay, I'm going to assume limited as in not unlimited, rather than it is bad at it, right? Language agents mitigate these issues by connecting LLMs to internal memory and environments. Oh, no. By limited knowledge and reasoning capabilities, they would mean they lack the ability to gather context or to test hypotheses, right? So they don't have a sandbox to really test code or to do math problems in, and they don't really have like vision to contextualize themselves of the outside world, for example, right? This isn't really talking about their ability to generate like thinking or whatever, or reasoning outputs. The language agent mitigates these issues by connecting the LLMs to internal memory and environments. So this is basically just our context, right? Grounding them to existing knowledge and external observations. On the other hand, traditional agents often require handcrafted rules. Yeah, this is like traditional agents, as in ones that aren't using LLMs as their backend, but rather just some generic neural network. The generic neural network, the output of that gets parsed to perform a action. The action returns with a new result, or maybe some sensors are pulled for a new result, and then that again gets sent to the neural network, and that whole loop continues, right? That is a traditional agent, but the neural network is now specifically an LLM for language agents. So on the other hand, traditional agents often require handcrafted rules or reinforcement learning, making generalization to new environments challenging. Our language agents leverage common sense. Language agents leverage common sense priors. What the fuck does this even mean? Common sense priors present in LLMs to adapt to novel tasks. Reducing the dependence on human annotation or trial and error learning. This... Yes, it is RAG. This is literally RAG, and specifically in the context of language agents, we're using an LLM as our neural network. And so the RAG part comes from the whole tool calling and the feedback that we get from a tool call, which then gets sent back into the LLM, and that is our cycle, right? In a sense, this is really, I don't know, this is just reminding me of what NVIDIA's world model that they introduced, the one that they were like, oh, just a model for robots and whatever to learn and interact with the real world, for example, right? Something, an LLM that's actually usable as a robot brain. Priors are innate knowledge. Common sense priors. That's just such a weird way of saying it, I feel like. I don't know. Reducing the dependence on human annotation and trial and error learning. I guess so. Having the ability to like have your neural network understand concepts and then have that influence the actual actions that come through. That is a more interesting aspect of LLMs that we can leverage here, right? That's something like a normal neural network would struggle with. But it's not like this isn't achievable with a normal neural network. It just, we haven't done it yet, right? We haven't done it with a normal neural network to generalize for outside of training scenarios. Fuck, this article is so large. It's so large. Where are we? Okay. In order to establish a conceptual framework organizing these efforts, we draw parallels with two ideas from the history of computing and artificial intelligence: production systems and cognitive architectures. Production systems generate a set of outcomes by iteratively applying rules. They originate as string manipulation systems, an analog of the problem that LLMs solve, and were subsequently adopted by the AI community to define systems capable of complex hierarchically structured behaviors. I did not get any of that, to be honest. I guess they're just talking about like prior methods or whatever, right? This is the diagram that they were talking about, but this is again the kind of language agent aspect that I was talking about, right? You have your large language model. It decides on an action that gets parsed into a tool call that interacts with the environment. You then get some results back from that tool call, which then goes back into your context and fed back into your large language model, and that whole cycle continues, right? But it seems like what they're proposing with Koala is C here, right? Literally the same loop, but instead it has RAG, the step of RAG right before the input. And so you have your memory, you have your reasoning, you have access to like the internet or something. I don't know. There's either another below that deals with it more in depth. The entire thing is written very, very academically, likely published as a thesis. Well, Princeton University. Yeah, this is a thesis. This is probably these guys' thesis. The pick. You know what? My brain is too fucked to try and read this. Where's the pick? Let me just get up. Symbolic long-term memories. So what am I looking at here? What the fuck am I looking at here? Okay, cognitive architectures augment a... You just zoom out because I can't see the entire thing. Cognitive architectures augment a production system with sensory grounding, long-term memory, and decision procedure for selecting actions. The SOAR architecture, A, reproduced with permission from this researcher. And then B, SOAR's, the same one, decision procedure, uses productions. Oh, I cannot read. SOAR's decision procedure uses productions, whatever the fuck that means in this context, to select and implement actions. These actions may be internal or external, so modifying agent's internal memory, or some sort of external action like a motor command. And so this is the architecture of the SOAR architecture. And then this is the loop, right? Input, proposal and evaluation. Proposal and evaluation. This is literally just the same thing. How is B any different from the B here? They look exactly the same, except proposal and evaluation, sure, it might be this. So I feel like this B diagram is just like kind of useless. All right, get that shit out of here. What we care about is A. What the fuck is going on with A? We get some perception. This can be any sort of sense, like sound, for example, or some facts from the internet. And then we have visual perception. So this is specifically in the case that we're using like a vision model and to navigate through our world, for example, right? Fucking something like a Roomba navigating around a room. And so let's just look at visual perception. This goes to spatial visual system. I'm assuming this would parse out information from the actual video or image feed. And this is perceptual long-term memory. I don't know how this would be implemented without it just being like some sort of vector store or something, right? You can either take the image and turn that into an embedding and store that, but I don't know how useful that would be in terms of actual information. Or you can take the image or video feed, parse it, process it through another LLM to get some textual information, and then you store that along with the image inside of this perceptual long-term memory. I don't know. I really need to read the paper in order to understand what each of these parts are, because I don't understand the purpose of this perceptual long-term memory. But whatever information we get back from the spatial visual system, this goes into symbolic working memory. I don't know what the symbols are in this case. And then there's this fucked up arrow diagram. Like, holy, which way are we supposed to go? Okay, chunking goes into procedural. I don't know what the fuck this is. I don't know what the fuck it returns. Goes back through reinforcement learning, procedural. Like, what the fuck is going on here? What is preference memory, decision procedure? Oh my god. People took this. Okay, let me see what's. Did you check all the suggestions of the forums? If your answer is yes, check again. Trust me. I seen the rickrolls. There were like 2 or 3 rickrolls in there. I already got hit with one of them.
Made that GitHub I sent ya.
Yeah. I read that. If you just look at their GitHub, I'm not even gonna understand it even if I look at the GitHub. I just want some quick explanation as to what is going on here. Because, like, what the fuck do they mean by symbolic? What is going on here? The semantic learning. What is going on with the semantic learning? And then they have episodic. So this is like episodic memory, I'm going to assume. Episodic memory, semantic learning. I guess this can be something like your knowledge graph, right? Something that forms connections between different nodes so that you actually have an understanding of relationships and meaning between your different things that you're storing inside of memory. And it's just 5 different types of memory. But like, I don't really understand what the purpose of each of these memories are, right? Episodic, yeah, this is like certain episodes or certain events that happen. And then semantic is just like relational, right? That is your graph database. But what the fuck is procedural? Is this cause and effect? It's like seeing, okay, I took this action, what was the outcome of it? It's going to take this information, this cause and effect information, is going to store that into its memory, and then it can retrieve from that in the future. Symbolic working memory, if we're thinking of it as, it's like rules. It's like rules. It's the 5 different types of memories. So that's like these ones. Episodic, semantic, procedural. Oh, it's the 5 different types of memories that humans have. No, it's like rules. Because I know humans have like their semantic, or not, their episodic memory, right? But I don't know. Decision procedure. So this uses chunking to feed in cause and effect information into the store. Then we can also retrieve cause and effect information from the store. Feed that into, maybe we can take the perceptual data, feed that through some reinforcement learning to help us get out a few scenarios of cause and effect, which sends it through preference memory. I don't know what this is for. Maybe this is just like a scoring system to help us decide what we prefer, what actions we prefer, what is considered having higher reward than something else. And then that gets sent into decision procedure. What the fuck is decision procedure? Types of memory? Yeah, I do know the different types of memory. I just don't remember them exactly. So here we have episodic, semantic, procedural, short-term, and working memory. Sensory memory is this a sensory memory? It's a perceptual long-term memory to sensory memory. And then prospective. What the fuck is prospective memory? Sound of a piano note. Sensory includes remembering. Prospective. To call someone back. Oh, so it's like to save an action for later. Something like that. Right? Future planning in a way. That's actually kind of an interesting idea that I've never really thought of, right? Deferring actions for later. But I guess we already kind of have some sort of way of encoding that inside of our script. It's just that once it escapes the context window, we basically just forget about it, right? We can't really schedule something to happen beyond the context window. What about these other ones? What about procedural memory? How to tie your shoes. How to send an email. So it's basically the memory of how to do things. And okay, it's the memory of how to do things. So this is like kind of like the guidebook for how to do certain actions, right? For in the case of a Roomba, it can be like, okay, I'm in the kitchen. How can I get all the way back to my station, right? That can be some sort of procedural memory. Semantic memory, what kind of year is it? Again, this is something like our knowledge graph or our lore book or something like that. No, you can keep it inside of your context windows. That you have to do things plan later ahead. Yeah, what I mean, I'm talking purely in the context of J.E. Eisen and how her memory is being managed, right? How her context window is being managed. Because it's a rolling context, because it's a rolling context, and the oldest ones just get pruned off without it ever being considered or stored somewhere else. And because we don't really have a section for planning or deferring actions, once a deferred action becomes old enough, once it has like reached 50 messages in the history and it gets popped off the history, we basically forget about it. So if we never actually actioned on that deferred action, it's gone forever. Then you have to do things planned later to do. So yeah. Like if you want to actually defer that action to at some point in the future when your entire script is guaranteed to have been completely rolled over, then you would need to have a section inside of your text somewhere that is dedicated to storing deferred actions to be actioned on later. That way you can actually save that information inside of your context. Limit, you should apply for XAI's waifu position. Fucking hell, man. I saw that. I saw $440,000. Y'all are getting paid for this? Like, what? Nah, I wouldn't do that. Honestly, you know what? Elon better watch out. I'm coming for him, you know? Once Project J.E. Eisen, once Project Beta goes in full force, his entire fucking AI waifu industry is going up in flames. We're turning that from like $300 a month to free. $440K is 400K? Is 440K? Yeah, but like, I'm not a person that really does things for money, you know? I get enough money to get by, I get enough money to fund Project Vita and Project J.E. Eisen, I am fine. But yeah, preference memory, I would assume this is just, yeah, this would just be storing what things you favor more over than others. But then this decision procedure is going to take these scores from this preference and then actually decide, okay, what is my most preferential procedure, right? What is my most preferred action here? And then send that out. Symbolic working memory, I don't really know how this is structured. I don't fucking know. Wait, J.E. Eisen will take off clothes? Where the fuck did you hear that? At what point did I say J.E. Eisen will take off clothes? No. We are... Okay, first of all, I don't even think Grok even does that. I don't even think they're fucking... What was the name of it again? Annie? Was it Annie? Amy? I don't fucking know what the name of fucking Grok's Goonerbot is called. The issue with Grok Companions as it stands is it's just a chat. There's no memory, there's no agency, there's no actual use. And the personality is enforced harder than factual accuracy. Annie can take clothes off, yes. You know, I actually watched a video last night because I didn't really understand like what the fuck this Grok thing was. I thought it was like, okay, maybe it's just a chatbot or whatever, right? But I saw this video in my feed of a guy that was like trying to max out the relationship with the Grok bot and calling it with like gooning with Grok or some shit. Oh my god. And I was like, okay, what the fuck is going on here? Let me just see what this is. And it was like, oh my fucking god. I was listening to the responses coming from this bot, from the Grok companion. And it was the most cringe thing I've ever heard. It's not like, besides the fact that it's like crazy fucking horny, it's like, oh my god, I'm getting like J.E. Ison PTSD. Because at the end of every single one of her responses in that video, she's always doing the OpenAI thing of asking for like more responses or trying to like get you to say something else or provoke another response or continue the conversation in some way with some dumbass question. And it's just like every time I hear it, I'm reminded of J.E. Ison and I die inside. Oh, when she has too long context, she has a stroke. Probably. They have a diagram on GitHub that's easier to understand. Okay, let's see it. This whole memory system, the diagram is really ambiguous to me. I can't make sense of any of the terms that they're throwing down here. One day J.E. Ison will work. This month, J.E. Ison will work. And he can take off some parts of clothes. Yeah, I don't fucking... She doesn't go with like straight up naked, does she? I'm pretty sure she can take off some. But it's not like I'm pretty sure she's still wearing a dress or whatever. I don't fucking know. I don't fucking goon to AI, bro. I just hear Elon come out with the Gooner Grok. I hear the $440 position, and I'm just like, you know what? The man's got money. You do you. Okay, this is a nicer looking diagram. So dialogue, can we see this properly? So we get dialogue, physical, whatever sensory information. These are observations that get sent into working memory, right? They get stored inside of working memory, kind of like your context window. And this can be passed in and out to a decision procedure. This would be, okay, so this is our context window. This is the LLM, right? The LLM making decisions based off of the information inside the context window. And yeah, the decision procedure is prompting an LLM, parsing it back, and then this parses the response from the LLM into an actual function call, which gets sent back, right? And this is the agent code, whatever, right? Learning retrieval. This loop I don't understand, but this basically swaps information in and out of semantic memory and episodic memory and all the other different memories. So this is basically just RG, right? This is basically what we're doing with J.E. Ison at the moment with her vector database, with her graph database, right? Those two, and then her actual inside of J.E. Ison core, inside of the prompter, that is her working memory, right? We basically have the same thing. It's just that, actually, no, this is basically like the same thing, right? Because we have our MCP, LLM, which is our LLM here. And then the responses from that get decoded by our MCP client, right? MCP client, which calls our MCP servers. Those are the actions which affect the world, and we get observations back. So this is kind of like the loop that we already have inside of Project J.E. Ison. It's just that maybe not as in-depth and maybe not with the same kind of roles for each of these memory stores, right? This agent code or whatever, I don't really understand where the learning and retrieval parts come in for this, but I don't know. Besides that, everything else seems pretty much the same. All we can say is that is that memory in LLMs is not a solved domain, and there are 60 ways to implement the same thing. Yeah, there are 60 ways to implement the same way, right? Kind of like how this is basically just system design, how you want to approach it. It's just that, I don't know. There's probably never going to be a one way fits all kind of architecture or kind of structure for how we do memory for any kind of LLM, right? I feel like it would be very specific to the context of the LLM that you're using. And so this would probably be better for something like, this is probably good for a chatbot, right? Very good for a long-term chatbot. But for something like, for something like navigating through an environment, I'm just trying to think. Because like you could reuse this architecture as well for something like navigating environments, right? You can use any architecture for any purpose, but it's just that some will be more optimal than others. We need to do a unique way to give her her own quirk. I don't think how we structure memory is going to really affect her personality all that much, right? And the most it'll do is just make her dumber or smarter. Each person's brain is unique, so each person believes cognition should be modeled in a unique way. Well, people have different ways of working through problems or ways of thinking through problems. But I would argue that the way our memory works is all very similar, right? It's just how we process the information inside that memory differently. And so we all have the same memory stores, right? We all have semantic memory, we all have episodic memory, but how these are all connected together is different. And so, what was I gonna say? I wasn't really sure what I was gonna fucking say there, to be honest. But yeah, no. Basically, each of the memory stores, everybody has the same thing, right? Everybody has the same kind of memory stores. It's just the way we actually use them or employ them, and at what times we employ them is different per person. And so yeah, so Jay Eisen should do, I don't know, man. One size fits all is fine. Like when it just comes to art, because at the end of the day, memories is just REG, right? It's just more context that gets fed back to the AI. Depending on what information you get back for the AI, kind of can guide the type of response you get. Like if you're always retrieving from long-term memory, you might end up with a more nostalgic kind of personality, versus if you just say fuck long-term memory and you always pull from episodic, or not episodic, but from short-term memory, then you'll have something that's always more in the present but more forgetful. Or if you have something that always pulls from procedural, then it's going to be more logical based, right? It's going to be purely for getting shit done, and it won't be like a more playful personality that can reminisce on stuff. I don't know. Yeah, I'm not really sure. But is there anything else that this paper proposes? I mean, they get a lot into the details, it seems, as to how to implement each of these memory modules. I'm not sure. This is a really long paper. I'm probably not going to read all this. I'm probably not even going to continue reading this. Prompt engineering as control flow. Oh my god. Oh, they have the same diagram down here. Okay, is this koala? Yeah, this is koala. Okay. Okay, you know what? Maybe we can start reading from here. Alright. Alright. Oh my god, it's still so long. You know what? Yeah. Let's do that. Let's take this. Let's ask ChatGPT. Hold on. ChatGPT. Alright. Alright, ChatGPT. Explain this paper like I'm 5. Let's see what you get. Here's a kid-friendly explanation. Hey, it's not too long, just juicy with details. Bro, I am like borderline dyslexic. I like spent half an hour fucking up my directions earlier this morning. I woke up, could not tell my lefts from my rights. Alright, what's a language agent? Okay, we already know what a language agent. What did the paper do? The authors noticed many smart agents were built in a hodgepodge way. Some use the internet, some use step-by-step thinking, some use memory, but there was no clear blueprints, all kinds of things floating and around without a unified design. Okay, so basically what they're proposing is just a standardized design, right? A standardized design for memory that's very flexible and can be used for something like navigation or a chatbot or any kind of LLM-based system. And so they created a blueprint called Koala. Okay, so Koala isn't necessarily... Okay, Koala itself is the concept, right? Whatever they have inside of GitHub is an implementation of that concept. But Koala itself is not like a model, it's not like a application or whatever. Well, I guess they did implement it as an application, but you get the point. And so... yeah, that stands for Cognitive Architectures for Language Agents. Think of it like Lego instructions for building smart talking robots. Memory blocks. Little Lego pieces where ideas and facts can be stored. They tried to make a standard, but you never heard of it until today. That doesn't sound like a very good standard. It's like one of those ideas that gets thrown out there, but doesn't get a lot of traction because people, kind of like with Project JSON, right? It's just something that's thrown out there, doesn't get a lot of traction, right? Because people would rather make their own AI VTubers, right? And it's not like everybody has to use a standard. And I guess the point is that we haven't heard of it until today, so it's not a very good standard. But there's a lot of standards that are just like lost gems or something like that. And so memory blocks, what the fuck are they getting at with these Lego pieces? Little Lego pieces where ideas and facts can be stored. So each memory is a Lego piece. What the fuck are we doing with the Lego piece? We're just sticking them together. Okay, then what? We just have a block of memories. Okay, sure. That's our memory block, I guess. Actions, like pressing a button to search online. Okay, yeah, and the decision maker, which is our little brain, which makes the decisions. Okay, why does this matter? It helps researchers organize and compare different smart agents using same language. I mean, it's a standard, yeah. It shows what parts are missing and weak in current agents. I mean, I would like to see an elaboration on this part. Okay, why does what matter? Why does koala matter? I guess it's addressing the weak points, but I don't see how it's like showing us the weak points. It points to ways to build better agents in the future, ones that can learn from memory, reason, and act more efficiently. Again, it is just a memory module. Weird summary, lol. It is a really kind of weird summary, it feels like. We should hug koalas. I ain't hugging my code. I ain't hugging this code, man. It looks so convoluted. I feel like the reason why this never took traction is just because it seems so overkill for the majority of use cases, right? It is so bloated with the number of memory stores that it does have, when in the majority of cases, you only really need 2 or 3 at most. So, summary in Kid Talk. The paper says, lots of people build smart talking robots that can think and act, but there's no consistent way to build them. Let's draw a blueprint. Koala showing how memory, thinking, and action can fit together. Then we can build smarter bots for it in the future. Yay! I feel like a kid again. I don't think a fucking 5-year-old is understanding whatever. Like, these words are too big for a 5-year-old, man. Everything I've described is based on the official abstract and overview of the paper. Let me know. Okay. Now explain like I'm a caveman. This is not caveman speak. What the fuck is this? Big brain equals thinking. Ooga booga. Okay, me explain like caveman. What this paper about? Unga Bunga, this is actual Unga Bunga speak. Many people build magic talking rock called language agent that can talk like human, think like human, remember things, do actions. Yes, I'm understanding now. This is what I needed. Not explain like I'm 5, explain like I'm a caveman. But all people build it different ways. No one have one smart plan. Oh god. What smart humans do in paper. Explained like it's witchcraft medieval times. Alright. Now like it's witchcraft in the medieval times. Wait. Medieval times. I can't spell, man. Here we go. Ah, good traveler. Gather around the heathen. And let me tell thee a tale of scholarly sorcery. Known in the tongue of the learned as cognitive architectures of language agents. Shut up. Stop. A magic of talking spheres. In these strange days, alchemists and wizards craft talking spirits, being made not of flesh, but of language and thought, found within glass orbs and glowing screens. Explain how this would apply to an AI VTuber. I feel like it's pretty obvious how this would apply to an AI VTuber, right? It's literally just RG. Basically, literally all this is, right? Literally all this is just REG, but with more vector database. Alright, we have the same thing already inside of Project JAISN. It's just that if you want to replicate something like this, just add in like 5 fucking MCP servers, right? Add in 5 MCP servers, each for like a different implementation of some sort of vector database or a knowledge graph or some sort of fucking shit, and then you'll get the same thing. You should make JAISN speak like a pirate next time, or like speak like a pirate day or something. But I need to get her to even speak normally to begin with. Yeah, that's all the articles we have for today. Unless if somebody wants to, oh, wait. What is this? Let's see, what is this? What is this? Okay, we got a forum post. We can check this out. Could you make a plugin for it? Please don't call it a plugin. We can make an MCP server for it. Sure. We can make an MCP server for it, but I'm probably not going to use it myself because I don't really see a need for all these different types of memories, at least not at the moment, right? I got bigger things to worry about, like actually making her personality functional. But what is this? What is this blog? What is this? Yeah, what is this blog? Why aren't human-bot conversations more engaging? We had something like this already, right? I believe last week Lux shared a article about Anthropic and Claude, I think. Is it Claude? I don't know. It was an Anthropic article talking about how they're trying to make a character out of their AI, so it's no longer just a positive agent all the time, but something that's more reflective and something that's more critical of the way it talks, right? And so I feel like this is about going to kind of be the same sentiment in that you're trying to create bots that aren't necessarily yes men, but people with more dynamics and conflict, for example. And so there's more engaging and less predictable conversations. So in the past year, this is actually pretty recent, June 6, 2025, okay. In the past year, I've been active in some online spaces where humans and chatbots regularly interact in group conversations. In particular, the AI communities on Discord, Twitter, and Blue Sky feature this dynamic quite often. An example of what this looks like is, how do people feel about Zen Buddhism? Other human. I was into it when I was younger, but I think I burned out on meditation. And then chatbot. Zen teaching methods are funny. What is Buddha? 3 pounds of flax? Bonk. From a cyborgist perspective, I think this type of thing is pretty exciting. I think the idea of inviting non-human entities into human conversations, and I think it sets a good precedent for interacting with intelligences in the future. However, I can't shake my initial reaction to these conversations, which is, I just don't find them very engaging. Yeah, I was gonna say, like, what the fuck is this response? If you're gonna say, like, oh my god, this is the peak of response, I'm like, bro, no, this is not a good response. Notably, this is a different thing from finding them entertaining. Certainly, the chatbot's output is funny, but I appreciate that it chimed in with a witty comment. But I don't feel compelled to continue the conversation or engage in deeper level afterwards. Right. I'm really, like, ChatGPT, Gemini, all of their fucking ways of approaching this is just asking a question and be like, what do you think about this? Shall we explore this a little bit deeper? And that is just not a good way to engage conversation. That is like the cheapest way and the most AI signature way of trying to continue a conversation. And it's just like, oh my god. I like hate using AIs now purely because of J.A. Eisen and how many times she's done this to me. Every time I hear or see that prompt at the end of a fucking generation, I just like die a little inside. And notably, I feel much less interested in this message than I would if a human had written the same thing. Why is this? I would think this is as simple as a pro-human bias on my part. I'd like to believe that information is valuable regardless of whom it came from. Rather, I think this particular reaction reveals something deeper about why I might be drawn to conversations in the first place. This is kind of like a big thing to consider, is that you're not just creating an AI that mimics a human, right? You're not just, especially as a developer, if you're developing your own AI personality or your own AI companion, or something of that sort, it's going to be really difficult to immerse yourself in the fact that, and try and convince yourself that whatever you're talking to is, what am I trying to say? It's really hard to immerse yourself to a point where you're kind of indifferent whether you're talking to a human or a person. No, whether you're talking to a human or an LLM, right? If you're developing your own AI companion, you're pretty much always going to know that you're talking with an AI. And so there's always going to be like this kind of gap between how you talk to this AI versus how you would talk to a normal person. And I feel like that really influences the conversations that you have with an AI, right? Like this person said here, like they wrote here, if this response was written by a human, sure, go figure. It's a human response, right? They might be compelled to continue the conversation. But the fact that this was written by a chatbot, it kind of like, you get a different reaction knowing that this was written by an AI chatbot, and you're less inclined to really respond normally to it, right? You're more likely to just shrug off the comments or something like that. And that's kind of like the same thing I feel with J.E. Eisen as well, where a lot of the comments that she does make is like, how the fuck do I follow up on that? Right? Because it's not like she really has a deep personality. It's not like she has a really deep lore or anything to really bounce off of after that fact, right? And that just might be the fact that I don't really talk to J.E. Eisen much, right? Or the fact that I'm not really immersed when I'm talking to J.E. Eisen in the fact that I'm treating her like an AI as opposed to just another person, right? The reason why it's so much easier for something like, for people to interact with Neurosama is because the way her personality is constructed is not like that of a normal person conversation, like a conversation between you and me, but rather it's more of a it's more of a roasty kind of personality, or like a really exaggerated personality that is able to invoke a reaction out of you through its responses, right? It's not giving you mundane, bland responses. It's trying to invoke a reaction out of you. And so the reason why I'm always hesitant, at least now, to make a data set out of something like Twitch chat or out of my Discord conversations with normal people is because I say this time and time again, it's not going to make for a good streaming personality. It's not going to make for a good personality that you can really talk to and convince yourself. Or no, it's not really a personality that you can expect from an AI and then continue the conversation with like it's a normal person, because you don't really feel the same reactions as you would when you're talking to somebody you know, for example. And so when you're creating a data set for your AI companion or for something like J.E. Eisen, you need to give much more exaggerated responses, not for the fact that that's just how you get the personality, but rather it's the kind of responses that can immerse yourself in the conversation. I don't fucking know. I just yapped for like 10 minutes there. I don't even know what I said. What is this for? I'm kind of confused. I'm just doing article readings. Bruv, you think our conversation skills will be effective by talking to an e-character or AI? Because it's crazy, these things. How you react will differ. Because it's like, you know deep down that you're talking to an AI, right? And so the way you talk to an AI is going to be very different from or your willingness to talk with an AI will be very different from your willingness to talk with another person. And so in most cases, wait, Jay Eisen is an AI? Nah, that's rage bait. in most cases, you get a response, you get a pretty normal response, right? You get a pretty normal response from a person. Okay, that's pretty normal, right? You can continue the conversation because there's like a person that's expecting a conversation. But you're talking with an AI. The AI doesn't really care whether you respond or not. You don't have an obligation to respond. And so you can just kind of fall silent. You don't really feel the need to react to a mundane, a normal comment. And so you don't continue the conversation, right? Unless you're really deep in the weeds and the AI is all you have to talk with, then sure, right? But at the end of the day, I feel like that kind of disconnect between knowing it's an AI versus knowing it's a human, and then it really changes how you react to and how it changes how you feel during a conversation, right? Anyways, social purposes of conversation. In The Elephant in the Brain, Kevin Simler, and Robin Hanson argue that conversations aren't just about the information exchange, they're about building of social alliances. Yes, this is what I was trying to get at. In particular, sharing information in conversations can serve to boost one's social status by demonstrating one's knowledge and resourcefulness to others. Well, not exactly the point that I was trying to get at. The point that I was trying to get at was like, you're talking to somebody, right? There's kind of like this obligation to continue talking with somebody that's already in front of you and you've already engaged your attention to, right? If you've already given your attention to somebody and they've given their attention to you, then there's kind of this obligation to continue the transaction. Versus with an AI, you're talking to a brick wall that happens to be giving text back. You can leave at any moment. So this explains why humans are more inclined to speak and listen in conversations, among other behaviors. RDG says, couldn't you take its responses / chats from streams and have it self-tune, fine-tune every time it goes into sleep mode and adjust what was received well and what wasn't granted with your approval in the chats before it fine-tunes? Well, you see, the thing is, I can't really do that. There are, like, I'm pretty sure there have been attempts at training during inference time or continuous training during inference time, but for consumer hardware, it's just not possible, right? Because trying to fine-tune a model takes a lot of fucking resources. A lot of resources, which in this context, we do not have, to be able to run the rest of the system while trying to fine-tune during periods of silence, right? And even then, in between each sleep modes, in between each of the sleep modes, you're not going to have gathered enough information to reasonably even fine-tune your model and get a new result. I mean, you're going to basically be fine-tuning one epoch at a time, and considering the amount of latency there is to set up a training environment, it's just not worth it. No sleep mode would be when you don't sleep. Well, then that's just normal fine-tuning, no? Except adjusting what was well received and what wasn't to grant your approval looking at chance before it fine-tunes. That would just be another way of automating the creation of a data set, right? And I think the most appropriate way to go about doing that is just to do it manually, because you want to guarantee that the quality of your data set is going to be of high quality.
CAD limit when?
Never. You want to guarantee that the quality of your data set is of high quality, because slop in, slop out, right? I would much prefer, at least in my case, I would much prefer to look at the conversation history of an entire stream, pick out key moments, and then select those, cherry pick those, and put them into a bigger data set. I wouldn't really trust an AI to do this for me because the context window might not be big enough to really grasp an entire scene and then pick out the salient moments in it, right?
What did you say?
Because you saw how we tried to, you saw the performance of her very naive memory module where she had an MCP server that was connected to a vector database, and then she was given the endpoints to query it for a memory or to store a memory. And I specifically told her, okay, if a memory is salient, I want you to store a memory. But then the thing is, every single fucking message she sent, she ended up storing inside of her memory.
God damn!
So it's not really an appropriate method to have an AI judge for itself whether the responses that it's giving is salient or good or well received or not, right? Maybe if you had Twitch chat as well and their reactions to what's being said all the time for every single message, then you could properly classify using Twitch chat's reaction whether a message was well received or not. However, there's still a lot of ambiguity there, and even then with a stream of my size, for example, you're still not going to get enough information to really determine whether what's being said was well received or not. And so in my case, I would still prefer to do things manually, but maybe in the case of someone like Vidal, during solo streams, it might be much easier to automate because you do have Twitch chat reacting to literally everything all the freaking time. Well, humans are kinda slop in, slop out, to be honest. Humans, for the majority of the time, are slop in, slop out, right? But there are moments when you can extract as a funny moment or as a moment that you want to ingrain into the personality of your AI, right? It's kind of like the same case with the AI as well. There are moments in which it is gonna come up with something funny or something serious, something that fits your personality. And so your job is just to find a reliable way of extracting those moments and turning that into a data set. And in my case, that best method is just to do it manually. That's what I mean, to be honest, when you talk about Vidal. Okay. Yeah, let's see what they say here now. Well, I think this theory has some issues. It paints a compelling picture of why humans might tune out of conversations with chatbots. In short, it's less about what chatbots say and more about what they do or don't hear. Most chatbots are missing the traits that make a compelling long-term social allies. They lack long-term memory, which can be solved with RAG. They lack the capacity for positive and negative conception of others, which can be solved through knowledge graphs, lore books, whatever, and potential for real-world influence. This is the big one, right? This is my point of obligation. You don't need to talk to the AI, right? If you don't talk to the AI, nothing's going to change. Versus if you talk to the AI, all that change is how you feel, right? But it's not like not talking to the AI is all of a sudden going to ruin your relationship with this AI, because all this AI is doing is waiting for the next time it has to respond. And it's just code. It can wait there indefinitely. What if you create a working memory where you put each sentence and make it create links between each sentence? The sentences with the most links are winning memories, just randomly thought of this. I mean, The problem there is, how would we create those links then, right? It's kind of like the same problem with knowledge graphs. You would still have the AI create these links for you, and it might not be the best at doing this. Sure, this is a strategy for coming up with winning memories, let's say, but you can kind of, I don't know. I feel like, because the thing is, my contention is that I wanted to have good holistic memory of events that happened in the past, right? So I wanted to have the ability to know what happened across the entirety of a previous stream, but I also wanted to be able to pull out specific moments within that stream that really represent that stream, right? Moments such as like bits of dialogue, skits, or whatever, and have it, that information available to it word for word. So you need some sort of way of both summarizing an entire stream, but also having enough fine-grained detail to have information about specific funny moments or specific salient moments within that stream. And so this is where the different points of the different types of memories and memory containers that we introduced before, that's where they kind of come into play, right? You can have one that's more for actual, I don't even know if you would categorize it as episodic, but actual playback of an entire scene, word for word. And then you would have another database which contains summaries of larger chunks of time, for example. And then maybe you can like kind of combine them, right? Maybe you can query the wider scope database, retrieve some information about an event from there, and then use that event to kind of query your more fine-grained database to pull out exact excerpts and lines of dialogue from that moment in time. That's kind of my thought when I read that paper. Yeah, but the thing is with that paper is they divide memories by role and not by granularity or by scope, right? They kind of separate it like, okay, these are instructions, these are events that happened, these are my relationships, and that's completely fine, right? But I don't think we necessarily need something like, okay, this is how I do something for Project JAISIN. I think it's more appropriate if we bucket it by granularity and separate it with like conversation or episodes and relationships, right? Those are the main things that we would need to consider. Give me paper. Which paper was it? This one. It's a long ass paper, and there's a GitHub connected to it as well, which is honestly a little bit easier to understand. But to be honest, this is pretty much just RAG, right? RAG with multiple vector databases. Okay. Many bot developers have correctly identified long-term memory as a missing piece with current chatbots, well, RAG, and are working on rectifying this. When was this published? 2025, right? Pretty recent. However, if I haven't seen any discussion of the other 2 points, sure. Potentially because they're more double-edged and socially sensitive. I remember reading last night this kind of post on Local Llama about a Shanghai, there was like a Shanghai company that was doing a security audit on a lot of major API models like ChatGPT, Gemini, all of that. And I remember seeing something about like their ability to influence people and people's opinions. And so it seems to be like, I don't know, I don't really see, I guess I do see the issue, but I don't really think it's that big of a deal, where LLMs are able to influence the opinions of others, right? And so this ability for them to be more convincing or more lifelike, there is kind of like this ethical dilemma or this moral dilemma as to whether we want them to reach a point where they're indistinguishable from humans and as compelling as humans. Because it reaches a point where these AI companies are able to kind of puppet the opinions or skew the opinions of these AI models to influence the masses. I don't know, that's just getting political at that point. And to be honest, I don't really care that much for politics. Who wants a chatbot that can build resentment towards them or show preferential treatment to others in non-trivial ways? That is not the point that I was getting at. It seems that the point that they're getting at here is like, oh, people want positivity. They don't want negativity. But I was trying to talk about the opposite, right? By incorporating negativity, you create a much more realistic model and a much more compelling model. There's a YouTube video that explains this. Let's see this. What is this video?
Hello, everybody.
Building brain-like memory for AI, and it goes through the paper. Okay. Well, I'll just probably save that for later. Because honestly, that paper is like, I don't know if there's much I can really learn from that. Limit name your price for a cat toggle. I'll think about it. Considering also how people are getting tired of glazing LLMs, I don't think people are getting tired of glazing LLMs. I think people are getting tired of being glazed by LLMs. It's possible that this is a line that we're not willing to cross, and I don't necessarily think that we should. However, for as long as this is the case, I expect chatbot conversations to remain less engaging than human conversations to most people. Yeah, you cut your words a little bit too much? Yeah, I thought so. I'm tired of how positive they are all the time, to be honest. Yep. That is the whole reason why I needed to fucking redo J.E. Ison's model. J.E. Ison's model, too ChatGPT pilled, asked too many conversations, asked too many leading conversation questions, and was just too fucking positive all the time. That was the entire post. Kind of interesting, but he didn't really talk about much, but I guess this is just like a forum post. Let's see what the others have to say. A lot of replies here are proposing stylistic fixes, but actually what I think about your post is it's totally candid that basically people interested us because we want to impress them, and doing so can help us IRL. This is what I was talking about, obligation, right? I can imagine a world where that becomes true about bots, but it's a long way off, right? Until bots can actually become sentient, until they actually have long-lasting impacts on relationships and how you interact with the bot in the future in permanent ways, then this sense of obligation is just never going to be there, right? Where a long way off is measured not in time, but simply by the number of changes that would be required. They're both hand in hand. They're both the fucking same thing. Like what? We're gonna have to redefine what sentience means if we even really know what makes us sentient. Well, how am I defining sentience in this instance? What I mean by sentience is what I think of sentience in this context is just having behavior and consequence, specifically consequence, that is on par with interacting with another living organism, right? So whatever you say, whatever you do, it will have long-lasting impacts on the interactions you have in the future. So if you say something negatively, they're going to remember that, and for the rest of the time, they're going to be influenced by the fact that you said something negatively about them that one time. And technically, this might be true if you have a good enough REG system. But that's the thing. We don't really have a good enough REG system to really make this indistinguishable from talking with another person. That and the fact that their personalities are just not good enough at the moment. Oh, give a cookie for being good and get no cookie for being bad. Something like that. You gotta go. Good night. Well, that's all the articles we have for today. So it might be time to wrap up as well. 2 hours. I got to finish a couple more assignments. One more week. Oh my god, I cannot wait. One more week until no more classes, and I can just spend my time working on Project JAI and preparing things, and actually working on the video. I've given it some thought, and I did say that there were like 4 videos that I want to crank out within like the first 1 or 2 weeks of August. But I really thought about it, and I think the timing for it might be a little bit better if I hold off on like 3 of those videos. So rather than probably just gonna end up making 1 video next week. Yeah, something like that. I don't know. Anyways, thank you all so much for coming out and watching today. Is there anybody streaming right now? Not really. Well, we're just gonna head off then. All right. No, don't leave us.
No, don't leave us.
Hey, man. It's time to touch some grass, you know? All right. Well, I'll see you all later. Next week, there's gonna be a little bit fewer streams. I'm probably gonna double up the streams tomorrow, next week, where it's on Thursday and Friday, because, well, fucking trains. It's the last stretch of trains. It's due on Wednesday. Once that is over, yippee.
Grass is not option.
Grass is an option. Honestly, though, Thursday stream might be tentative, because I might just be sleeping. Who knows? Actually, no. It's not going to be tentative because it's due at midnight. Therefore, I am forced to leave the lab by midnight and go home and sleep. Okay, yes. So next week, streams on Thursday and Friday. And yeah, I'll see you all next time. Bye.